Hi, this is the revision video for the upcoming 3Parle test on number. It covers fractions, relative numbers, powers, and scientific notation. Hopefully you've answered the questions that were posted on the PDF, and now we'll go through some solutions. So starting with calculations with fractions, we have three calculations here. The first one involves an addition and multiplication. The second one has got brackets with a negative and a division, and the final one is addition and division. So the first one here, remembering the order of operations, you need to do the multiplication first. So we're going to try and show all of our steps. So I write 1/5, that stays in the front, even though we don't do anything with it yet. You don't change the order. Order of operations is what we do first, not what we put first. So 1/5 stays at the front, and then we're multiplying the 3/5 and the 2/7. When you multiply fractions, it's the easiest thing you can do really with fractions. You multiply the tops and you multiply the bottoms. So that gives us 1/5. Again, it stays at the front. 2 times 3 is 6, and 5 times 7 is 35. So we have 1/5 plus 6 over 35. Now to add fractions, the denominator, the bottoms need to be the same. So the first one here, I'm going to multiply the top and the bottom by 7, giving me 7 over 35. Second fraction stays the same as it was. So now I have the same denominator of 35 each time. And now I can just add the tops. That's a requirement for when you add fractions or to subtract fractions for that matter. The numerators, so the denominators need to be the same before you calculate with the numerators. So we're going to have 7 plus 6 over 35, and that's going to give us the answer of 13 over 35. The second one. In the second one here, we must do the brackets first. Brackets take priority over division. So I need to do my 2/3 minus 1/4. Now they are not the same denominator. I need a common denominator. I can't turn thirds into quarters and can't turn quarters into thirds, but I can turn them both into twelfths. So I'm going to have a fraction over 12 for both of them. To turn thirds into twelfths, I need to multiply by 4. So I do 2 times 4 is 8. And to turn quarters into twelfths, I multiply by 3. So I do 3 times 1 is 3. The other part of my expression here, dividing by 5/6, I just leave as it is. Now I tidy up my bracket. I've got 8/12 minus 3/12, which is 5/12. I don't need the brackets around that anymore, and that's dividing by 5 over 6. Now when you divide fractions, you should remember the rule is to keep, change, and flip, the KCF. It's like KFC, but a bit messed up. So I keep my first fraction the same, 5 over 12. I change the symbol from divide to multiply, and I flip the second fraction upside down to become 6 over 5. Now, looking at this, I can immediately see that the 5 here and the 5 here will cancel each other out. So that gives me 6 over 12. And 6 over 12, you should be able to work out 6 over 12, well, 6 is going to 6 once and 6 is going to 12 twice. So my final answer will be 1 over 2, or 1/2. The third one here, I have a division and an addition. The division takes priority over the addition, but remember, we don't swap the order of writing. So the first fraction, 2/3, stays where it is, and I'm adding the result of my division. Now my division, again, I have to do keep, change, flip. So I keep the quarter, I change the symbol to multiply, and I flip the second fraction upside down. Then I multiply through. Then I multiply my two fractions together, leaving my 2/3 at the front. So I got 1 times 6 on the top, I got 4 times 5 on the bottom. That is 2/3 plus 6 over 20. Now I'm looking for a common denominator between 3 and 20. That's going to be 60. And if you're not really sure what numbers to use, just multiply these two numbers. They will always give you a common denominator. It might not be the smallest, but it will definitely give you one. So first fraction here, I want that over 60, so I'm multiplying 3 by 20, so I'm going to multiply 2 by 20. So 2/3 is 40 over 60. And then my second fraction, I'm going to multiply by 3. I've got 18 over 60, and 40 plus 18 is 58. So I've got 58 over 60, which you should be able to see simplifies. They're both even, both divide by 2, gives me 29 over 30, and that's as far as that one will go. So quickly, we'll just cover a little bit of simplifying fractions. Here we have 3. So I'm going to look at it like this. I'm going to say 36 can be written as 6 multiplied by 6, and 66 is 6 multiplied by 11. Now I've done that because I can cancel this 6 and cancel this 6. And that just leaves me then with 6 over 11, and that is the simplest form I can have for that fraction. For my second one, I've basically got 4 multiplied by 10 over 36 multiplied by 10. The 10s will cancel. And then that leaves me with 4 over 36. Well, 36 is a multiple of 4. So what I've really got here is 4 over 4 multiplied by 9. Now the 4's cancel. And by cancel, we mean that 4 divided by 4 is equal to 1. So although we cross them out, we cannot leave nothing on the top. So we would replace that with a 1. So we have basically a final answer here of 1 over 9. So 40 over 360 is equal to 1/9. And then the final one here, they're both multiples of 5 because they end in a 5. Not easy to spot this one, but this is 17 multiplied by 5, and 35 is 7 multiplied by 5. Again, I can cancel the 5s, and that just leaves me then with 17 over 7. In the test, you'll be asked to also simplify algebraic expressions involving fractions. So here we have 3. The first one, it's just a multiplication, so I could do it like this. I could do b squared multiplied by a to the 7 over a to the 5 multiplied by b to the 3. But really, that's exactly the same as what I've already got written. So actually, I'm going to erase that. I'm just going to say, well, I know I'm going to be multiplying them. Let's just see what I can cancel. Now, looking at it here, I have a on the top and a on the bottom. I have 5 a's on the bottom and 7 a's on the top, all multiplied. So these 5 here will cancel 5 of these a's here, leaving me with a squared. And the same works for the b's. I have b squared and b cubed. So my 2 b's on the top here cancel 2 of these, leaving me with b to the 1 on the denominator. What am I left with then? I'm left with a squared over b. Just as a side note, if I had something like this, a to the 7 over a to the 5, what that really means, I've got a times a 7 times, like this. I think that's 7, 1, 2, 3, 4, 5, 6, oops, 7. And then I'm dividing it by 5 a's multiplied together, not 5 multiplied by a, but 5 of them multiplied by a. And you can see here that when I do an a divided by an a, they cancel, they're just equal to 1. That's just something divided by itself. So all the 5 on the bottom cancel 5 of the ones on the top, leaving me with just 2 a's on the top, which is a squared. So that's where we get the a squared, and then the b works in a similar way. Looking at the second one here, it's a division. So as you know, we need to keep, change, flip. So I keep the first fraction, b squared over a to the 5, change the symbol to multiply, and then I've got b cubed over a to the 7. Now I can just look at the top, and I got b's on the top and a's on the bottom, so this is going to be nice. I got b squared times b cubed, so that is b to the 2 plus 3, or b to the 5. And then my denominator is a to the 5 times a to the 7, so it's a to the 5 plus 7, and that 5 plus 7 is 12, so it's a to the 12. Just as a point of note, if you look at the b's here, b squared is b multiplied by b. B cubed is b multiplied by b multiplied by b. And therefore, if I multiply them together, I have 5 b's altogether. So that is b to the 5. So that's where the rule comes from in terms of adding the powers. You wouldn't need to write that out. You could literally go straight from this stage here to your answer here. The one at the bottom is a bit more confusing. Again, we could write it all out and then give ourselves a number with an A and a B, and possibly a number with an A and a B at the bottom. But I just want to simplify it as much as I can. So I'm going to look at the A's first. Let's see how many I can cancel. I've got these A cubed here. A cubed at the top can cancel out 3 of the A's at the bottom, leaving me just A to the 1. Now I've got A squared on the top. Well, my 1A at the bottom can cancel one of these A's, leaving me with a to the 1. So what I've really done here, I've got a cubed times a squared over a to the 4, giving me a to the 5 on the top, a to the 4 on the bottom, which then will give me just a to the 1. Now let's look at the b's. So I've got b squared at the bottom. That's 2 b's. Take them off that 7, give me b to the 5. This b on its own is actually really a b to the 1, and that one can cancel one of these, giving me b to the 4. So the numbers won't cancel. The numbers here, I've got 3 and a 2, they won't simplify. So what am I left with? Well, if I look at the top, I've got 3, a to the 1, which is just a, b to the 4, and that is all over just 2 on the bottom. Now, being able to understand how to add and subtract and multiply and divide with negative numbers is important. Even though you can use a calculator, you still need to understand what is happening so you can really check your answers. Plus, of course, you might be asked to show your workings. So here's 5 questions. Let's go through these. The first one then, we have 3 plus 2 plus 5 minus 7. So the easiest way of doing this one is just to start from the left. I can do 3 plus 2 is 5, plus 5 is 10. So I have 10, and then minus 7, and 10 minus 7 is equal to 3. Next, you can see my numbers here, my negative numbers are all inside brackets. That's just to show you that this sign is attached to this number. This is a negative 10, and I'm adding negative 4, and I'm adding negative 5. So I'm just going to rewrite that. You wouldn't have to do this, but I'm going to rewrite it just to show you. It's minus 10, minus 4, minus 5. So minus 10 minus 4 is minus 14, and minus 14 minus 5 is minus 19. So that should be the answer that you get. The next one, again, the rules of priority of operations always counts. So we have here we have 6 minus 4 times 7. Multiplication takes priority over subtraction. So I'm doing this bit first. So I have 6. It stays at the front. Even though I'm not doing it first, the order of placement doesn't change, just the order of operation changes. So 6 minus 4 times 7 is 28. And then 6 minus 28 is going to give me minus 22. The next one, I have negative 8 inside brackets, which is fine, and multiplication, subtracting 2 times 2. So I have 2 lots of multiplication separated in a way with a negative. So I can do this multiplication and this multiplication at the same time, as long as I put my minus sign in between. Negative 8 times 7. A minus times a plus will give me a minus. So that is minus 8 times 7 is 56. And then I am taking away 2 times 2. 2 times 2 is just 4. So I have minus 56 minus 4. And that will take us to minus 60. The final one here, again, I have a multiplication and a multiplication, but separated now with a addition. 10 times negative 6, so a positive times a negative is negative, so that's going to give me minus 60, plus 9 times 10, which is 90, and minus 60 plus 90 takes me up to 30. The one rule not shown here is if we had a negative number multiplied by a negative number, and remember, if we had something like that, the answer will always be positive. So if I had negative 3 multiplied by negative 4, for example, the answer will be positive 12. So that's not shown in the examples, but it's worth making a note of that if you need to.